Alright guys, this is Miss Camp. I'm going to do a quick little video about everything that's going to be included in our 5th grade place value unit. And excuse my sloppy handwriting, I'm trying to record this on an iPad, so it's going to look a little bit like chicken scratch. One of the first things that we did during the year, and one of the most important things that's going to continue throughout the rest of the year and actually for years to come, is just understanding that our number system is based on the powers of 10. They will see that come up over and over and over again. We've talked about how when you are in the ones place and you jump to the tens place, why is it even called the tens place? Well, it's because you have taken that first place value and you've multiplied that by the number 10. How do you go from the tens place to the hundreds place? You multiply by 10. How do you go from the hundreds to the thousands? Multiply by 10. It'll do that over and over, including even the decimals. The most, of course, easy to understand decimals are these first two places, the tenths and the hundredths, because it's like money, but the students in 5th grade are expected to also understand the thousandths place, but understanding that it takes 10 thousandths to get to a hundredth and 10 hundredths to get to a tenth, kind of like 10 pennies to be able to get to a dime. On the flip side of that, kids are also expected to understand that the opposite is also true. When we go from all the way over here to in the whole numbers, when you start at the thousands and you go to the hundreds, you're obviously getting smaller, but by how much? Well, you're actually not multiplying by 10 anymore, you're dividing by 10. When you go from, let's see here, the tenths spot, which would be like a dime, to the hundredths spot, which is like a penny, how much does it decrease by? Well, it decreases by the number 10 because you're dividing by 10. So this comes into play because when your child is asked to do things like, let's see here, let me think of a number. If you have 54 and 162 thousandths and another number 5,416 and 2 tenths, your child might be asked to understand or explain why are those numbers different, which one's worth more, which one's worth less, and why. Obviously this number right here is going to be worth less, but explaining why is another story, or by how much I should say. And hopefully your child, especially with these two because they're using the same digits, they can understand that that number, it almost looks like it's been slid 2 places over. In fact, when it has been slid 2 places over, it's not just decreased by 10 anymore, it's decreased by 2 tens, which 10 times 10 is 100, so it's 100 times as great or either 100 times as less depending on which number you're looking at. And so they'll be asked to understand those sort of things. They might also be asked to look more specifically at maybe some of the same digits within both numbers and to understand that one of those twos is 100 times greater or 100 times less depending on which number you're looking at, and to understand place value in those terms. It could be just if it's a difference of 1 place value, it would only involve the number 10. If it's involving 2 place values, the number 100, 3 place values involving the number 1000, and so on. We've also discussed exponents a little bit, understanding that the large number is called the base, and then the small number is called the exponent. And we've discussed how when you see that exponent of a 2, it does not mean 10 times 2 is 20. That's usually the first instinct. It really means, the way I kind of start explaining it, is it means write down that base 2 times and multiply, because our system, just like on this other page, our system is based on multiplication and division, especially of the number 10, obviously. And so even when it comes to exponents, it's the same thing. So 10 to the second power is actually 100. It's another way of writing it. I tend to explain to the kids that we all have 2 names. A lot of things in life have more than one name. Like I tell them in school, they call me Miss Camp, but when I'm at home, I'm called Sarah, but I'm the same person. Same thing right here. The number 100 can also be called 10 to the second power. It could also be called 10 times 10, just another way of understanding those numbers. We've also talked about how exponents can also be used to represent place values. So if you have the ones place, tens place, hundreds, and I could keep going. And I'm not including decimals for a reason. In elementary school, the kids don't have to understand decimal exponents, so that's not necessary. It's just for the whole numbers. But everything is a base of 10. That's why people say our system is based on the number 10. It genuinely is, especially when you talk about it in exponential form. The ones place is 10 to the 0 power. And I kind of explain, I cheat a little bit in class and tell the kids that means it has 0 zeros in it. The number 10 can be represented by 10 to the first power. It's got 1 0. The number 100 is 10 to the second power. The number 1,000 is 10 to the third, and we could just keep on going. Of course, numbers never stop, but have them understanding those relationships between the exponents and the standard form, and how you go from one place value to the next is going to be essential. I kind of laid this out a little bit just to have the kids being able to see different ways to represent place values. Of course, these are only the whole numbers, but representing them in exponential form and standard form, word form, expanded form, those sort of things. And speaking of different forms, these are a few examples. These would be examples of word form that your kids would be expected to do in class. This would be an example of standard form. That's what we kind of view as the normal numbers. Expanded form, I feel like, is one of the trickiest because there's so many ways to represent it when you break apart each digit in a number. You can represent decimals when you have, you can say there's 9 tenths. Well, that means there's 9 1/10ths, and you can do that with decimals or fractions. Another popular way of representing expanded form is just simply breaking apart, but I still want the kids to be able to understand that that means 9 1/10ths. And there's even more than one way to represent. Hold on. Okay, guys, sorry. But yeah, representing numbers in different ways is also going to be expected of them. Especially expanded form will be the most challenging. Okay, one thing that we've been practicing since the first day is make sure we are understanding how to read and write decimals, whole numbers, but especially decimals correctly. Things like 2,314 and I'm just making something up, 507 thousandths. Understanding how to say the whole number portion correctly. It's sort of like its own entity a little bit. And making sure when you see a decimal, you say the word and then also understanding decimals, you sort of say it separately and as its own entity as well. So this would be 2,314 and 507, and the last thing you would have to say is the name of the last place value. So this would be 507 thousandths. If you had, let me switch colors here. If you had something a little different like, let's see here, we could even have 0 holes, and well, I'm actually going to leave it at that for just a second. Understanding that this could be read a few different ways. You could say 0 and 4 hundredths, but you could actually add an extra 0 right there and it wouldn't change the value of it, because you could also call this 0 and 40 thousandths. No matter which way you say it, understanding that you have to say and for the decimal, and you have to say the name of the last decimal place. So understanding that when you're reading and writing is going to be very important. We've also talked about comparing numbers, comparing decimals, understanding which one is greatest, which one's least. Even if you have things that are pretty challenging, like, let's see here, maybe something like 2 and 31 thousandths compared to 2 and 301 thousandths. Even though those look very, very similar, understanding that you start with the greatest place value, which would be always on the left, and my decimals are in the same place. That kind of helps sometimes when students are able to line them up. But understanding they both have 2 holes, so right now they look like they're pretty equivalent to one another. So that doesn't really help me. So let's move to our next place value, which would be right here in the 10th spot. And now it's pretty clear which one is going to be the greatest place value. So that one is the greater of the 2 numbers. That's really kind of as hard as comparing gets. Our last one is rounding decimals, and they're expected to round whole numbers, which they've been doing for many years, but they're also expected to round decimals this year, and they're expected to round to the tenths and the hundredths place. So if they have 4,621 and let's see here, 394 thousandths. Let's say they're expected to round to the nearest tenth, or that could also be written as a tenth. They need to understand that nothing has changed with the whole number, so they might as well go ahead and write that down and understand that that's going to stay the same. But our 2 choices are going to be either 3/10 or 4/10. We just have to be able to tell which one is going to actually be the closest. So we have this part right here. We have to use this 94 to help us. That's well over the halfway 50 mark. And so if it's well over, then you need to go with the greater of the 2. They're also expected to round to the nearest 100th, which could also be written like a decimal. And our 2 choices, let me kind of switch colors a little bit. Our 2 choices would still include, of course, the whole number. So we might as well go ahead and have that in our heads. But it's either going to be 39 hundredths or the very next one, which would be 40 hundredths. And in this case, when we have our 39 hundredths, we need to use this 4 thousandths to help us, and if it's not over that halfway, that 5 halfway, then it just needs to stay the same. And so when I teach rounding, I tend to make sure the kids understand what are your 2 choices. Which one is the number closest to? Why is it closest to that? Understanding those things are what is going to be expected of them. If there's anything else that you need help with, any other sample questions that cannot be found in your notebook or in this video, please just let me know, and I'm happy to send you some more information to kind of clarify some things. But we've been practicing since the first day of school on this unit, so hopefully everyone's going to do really well on the quiz. On the test on Thursday. Thank you.